Hi, welcome to Professor Kev Show. I got my buddy Joshua Landis with us from SparckCell. Good afternoon, my friend. How you been?
I'm doing fantastic. How about you, Kev?
Just living the dream, brother. So let's jump in. We
hmm
met we met obviously through the different speaker program. Tell us a little
hmm
bit about SparkCell and why you started it.
Sure thing. Uh, this kind of portable spectroscopy industry has always been a field that was really interesting to me. And recently, I found that there's a huge need, or there's going to be a huge need for chloride testing of things like either bridges or structures or foundations, especially because a lot of our infrastructure is starting to age, but also because the acceleration in hurricanes is going to cause excess saltwater ingestion into people's foundations and into the infrastructure that we drive, live, and work in. So I tried to devise a tool that would be able to be used in a portable fashion to scan tons of structures within a day, as opposed to current methods that either take a very long time to do an in-field analysis or require a core to be taken back to a laboratory. And so I kind of explored that market. I always had a passion for uh, optical devices, and this was an excellent outlet for that.
So tell me about the challenge of creating the device. Now, obviously, I'm not an engineer by any stretch of imagination, but that seems like it's challenging. And honestly, Josh, you have to get it right. Because
Yes.
like, oh, my bad. No, this is if you're going to use it, it's got to work.
Exactly. So you need to incorporate things like resiliency into the testing model. And in order to build a model of spectra to compare it against, you need to make sure that the uh, the features that you're putting uh, into your device are using spectra that's very well vetted. Or in my case, I'm just going to take my own spectra
Hmm.
with mechanical data that I know is valid. But the funny part is that the optics required and the excitation required for this aren't nearly as expensive as people would typically expect. You know, some of these lab machines are selling for $85,000 and they weigh several hundred pounds, requiring massive argon tanks. And there's a lot of devices and industries that take advantage of much smaller implementations of this technology. And so it's all about figuring out where you can grab those pieces from that you know work reliably in industry already and see how you can incorporate it into this brand new device. And you just have to get clever with it.
So crystal ball time, Josh.
All
What
right.
the future hold for you?
I would love to see this being used, at least this type of technology being used in industry more often. Kind of like portable spectroscopy is an industry that's heavily used by people like the Department of Defense, border security, and those are doing, excellent at their roles at, keeping us safe and identifying unknown materials or compounds. And they also have their place in climate investigation, things like analyzing and enforcing emissions of uh, harmful polluters and energy companies, which I think is really important. But I'd love to see these devices go in the hands of people who aren't spectroscopists, who aren't scientists, people who are able to use technology like this in a way that is accessible, in a way that's intuitive, because I believe it has tons of potential and I'd love to see it more popularly used in industry.
So what's the best way to reach out to you, Josh? How can people learn more, my friend?
The best way to reach out to me would be by my phone number, 978 602 7824, or my email, Joshua Landis 98. That's no underscores, no dots, at gmail.com.
Awesome. Josh, I appreciate you taking a few minutes to call on the show. And as always, thanks for being my friend.
Thank you so much for having me.
You're welcome.